The my screen is visible, right?
Yes.
Yes.
So coming to the last task, we completed the deployment, right? Deployment strategy. That was the last class, right?
Yes.
Okay. Today we can go with the monitoring. Okay. Monitoring means monitoring the Kubernetes cluster. Monitoring Kubernetes cluster using Prometheus and Grafana. So, what is Prometheus and Grafana? It's an open source tool. Okay. Prometheus and Grafana is an open source tool that we use for monitoring our application, that node, pod, everything we can, even container, the network, bandwidth, everything we can monitoring. Okay. After the post deployment of application into Kubernetes, we have to monitoring our entire cluster, right? I mean the infrastructure or application, everything we need to monitor. So we need to configure similar type of observability tools. Okay. So most common open source tool is Prometheus and Grafana. So the Prometheus Prometheus will collect, okay. Prometheus will collect logs and metrics from our cluster, okay. In this case, it's given a cluster, right? From the cluster. And Grafana will visualize what? The metrics and logs and everything. So Grafana is it's a web application, okay. It's similar like a web application. After installing, we need to log in using browser. So we will get a UI part, okay. So via the UI, we can see everything like how much CPU utilization happening in Kubernetes, how much memory, even coming to pod, we can see how many ports are there, how many nodes, and everything we can see like the visualization, okay. So Grafana need a data source to visualize everything, right? So in this case, Prometheus will the data source for the Grafana. So we need to configure that as well. So both are different service. So we need to install both in Kubernetes cluster actually. Okay. So we have a Kubernetes cluster. So we deploy some application. After for monitoring, we need to install both in the same cluster using the official image for this Prometheus and Grafana. Then we will access and configure our monitoring part. So here we have two node consider like that. Okay, so the Prometheus pod will be running here. Okay, and Prometheus also taking all that metrics and logs from specific nodes. Okay, here two node, right? So it will collect all the metrics and logs and sending to Grafana. Got it.
We can hear background noise now.
It's actually a pretty good singer at the temple next door, some spiritual singing going on.
Here's some festival actually. That's why I'm asking, is any noise from my side like that?
Hmm. What festival is it?
Due to festival, they put some speaker as well, additional speakers.
Oh, okay, loudspeaker.
Yeah.
At least he sings well.
It's not singing actually. It's I mean, playing some music.
Oh, okay.
Is that disturbed? All of you?
What did you ask, sir?
Is that background noise disturbing?
No.
Okay.
No, not for me.
Okay, I'm quickly spin up on Kubernetes. Okay. Okay, we have leveraging one more tool here. Okay, the tool name is Helm. We call it as Helm Package Manager. Okay, Helm is a package manager. So anyone heard about Helm Package Manager? So it's a package manager. Okay, that package manager contain some open source application YAML manifest. Okay, for example, we have a Kubernetes cluster. Okay, so we have to deploy some applications, some open source application like Nginx or Prometheus or Grafana, Fluentd. So many applications are there. Some open source community based application. So if we need to deploy that application to Kubernetes, okay, Kubernetes, we have to write the YAML file, right? Or we need to sort out the YAML file and we need to keep the YAML file in our local machine. So if we use Helm, we don't keep or we don't write the YAML file for the specific application, or even we can deploy our own customized application as well. So we need to liberate the Helm package manager. So in that case, what will happen? We need to install the Helm package manager in the local machine. Then from we need to update the Helm repository as well, okay, within our machine. Then from that Helm repository, we can search for that specific application that we need. And we need to use within a single command, we can install our application using Helm package manager. So don't bother about the YAML. That's the main benefit. And quickly we can deploy and upgrading like that using Helm. So it's nothing actually. It's a package manager contain. It's a repository. We can say the repository contain a lot of YAML files actually. Okay, in background actually there is a lot of YAML file they keeping, and we just leveraging the YAML and run it. So it will create the application in our own environment. And we called as these all that YAML file as stacks. Okay, coming to Helm stacks, STACKS. So all the packages that are specific application packages contained in the Helm repository. Got it? Read out all of you. No doubt, right? Regarding Helm.
Are we gonna go deep into the details of Helm, like
Yeah,
Helm chart?
we leverage Helm package manager for this Prometheus and Grafana deployment. So you
How
will
about
get more right.
I do see the requirements regarding Helm chart and everything. Are you gonna cover that one too?
Which one? Which one?
Helm chart.
Yes.
ഗണപതി തുരിതുണരുഗസുരപതി തന്നിമുന ഭഗവാനെ തുണയരുളുക ഗണപതി ഗജമുഖ ഗണപതി തുരിതുണരുഗസുരപതി തന്നിമുന ഭഗവാനെ തുണയരുളുക ഗണപതി ജയ 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 ഗണേശ 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 സുരപതി തന്നിമുന ഭഗവാനെ തുണയരുളുക ഗണപതി ഗണപതി സുരപതി കലിഗുണ ഭഗവാനെ തുണയരുളുക ഗണപതി ജയ 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 ഗണേശ ജയ 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 ഗണേശ ജയ 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 ഗണേശ. പശുപതിരഞ്ജക പശുപതിരഞ്ജക ദേവവിനായക നമ്പോധര ഗണപതി ദേവവിനായക നമ്പോധര ഗണപതി വിഘ്നങ്ങൾ തീർക്കേണമേ. ജയ 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 ഗണേശ ജയ 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 ഗണേശ ജയ ജയ ഗണേശ ജയ 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 ഗണേശ. സുരപതി കന്നിമുല ഭഗവാനെ തുണയരുളുക ഗണപതി ഗജമുഖ ഗണപതി സുരപതി കന്നിമുല ഭഗവാനെ തുണയരുളുക ഗണപതി ജയ 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 ഗണേശ 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 ജയ ജയ. ആവിരണ ശർക്കരയും തേൻകടലിൽ ഫലമുണ്ട് ഗുരുവരനെ വിയൊടി നാമമന്ത്രമതുണ്ട് ആവിരണ ശർക്കരയും തേൻകടലിൽ ഫലമുണ്ട് ഗുരുവരനെ വിയൊടി നാമമന്ത്രമതുണ്ട് തിന്മയമോട്ടെ തിന്മയമോട്ടെ കരുണാവാരിതേ കരുണാവാരിതേ പാവന കീർത്തെ ശുഭമംഗളവർദ്ധനേ പാവന കീർത്തെ ശുഭമംഗളവർദ്ധനേ നൈവേദ്യം തയ്യാറാണേ. ജയ 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 ഗണേശ 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 ജയ 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 ഗണേശ. ഗണപതി സുരപതി കന്നിമുല ഭഗവാനെ തുണയരുളുക ഗണപതി ഗജമുഖ ഗണപതി സുരപതി കന്നിമുല ഭഗവാനെ തുണയരുളുക ഗണപതി ജയ 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 ഗണേശ ജയ 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 ഗണേശ ജയ 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 ഗണേശ ജയ 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 ഗണേശ ജയ 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 ഗണേശ.
Did we complete it on-premise, I mean, self-hosted Kubernetes or Minikube? No, right?
No, you didn't cover.
Okay. So tomorrow we can do that, okay?
Also, deployment strategy. You need to cover
Canary, right?
what is,
Yeah,
canary deployment.
Blue-green deployed, right?
Blue-green, yeah.
So Canary, for Canary, we need to leverage some other tools, okay? Leveraging, there are different types of tools there to set up Canary. So one is the common one is Istio, then Nginx, Ingress. Several type tools we need to leverage to set up the Canary. So yeah, I'm planning to do Istio, okay? So we can, Istio actually is a service mesh. Service mesh. So we use service mesh to secure our Kubernetes, okay? Using sidecar containers like that. So one of the feature is Canary. We can leverage Canary as well using Istio. So after the Kubernetes, yes, it's completed, okay.
You need to update the kube control.
Yes.
No, 44.
Okay, fine. I think I installed Helm. Okay, so Helm version. Okay, Helm is also installed in this machine. So after installing Helm, okay, now we are going to leveraging Helm for installing the application, right? So coming to Helm concept, Helm package or Helm charts, okay, we call it as charts. So what is Helm chart means? It's a package that contains all the Kubernetes YAML files needed to deploy an application. So it's contain YAML for deploying an application. So the charts contain but the YAML files for the deployment YAML or service YAML. So whatever that needed for the specific application. Helm chart there, then Helm repository, Helm repo. Helm repo is a storage, okay. See, it's a repository, right? So it's a storage for Helm chart. So we have a lot of charts and we need to save. I mean, Helm needs to save that charts, right? So the repository contain all that chart. Similar like GitHub or Artifact Hub, like that. So in this case, I already installed Helm and you can see the version as well. So if we install Helm, okay, Helm install in the local machine, okay. So if we install Helm, then we need to use Helm commands. So first I am using Helm repo stable, okay. So it will, so this is a command, Helm repo add stable. I think I added the stable in this repository. Okay, you can see, yeah, stable already exists. So from that, we need to search for our own required application. Okay, our required application is Prometheus. So there is a official community-based package repository there for that containing official Prometheus and Grafana stack. So you can see using Helm package add, we need to define the application, I mean specific community name, okay, Prometheus community. Then we need to define that URL. So it will, whenever we hit enter, it's downloaded or it's cloned that package. So it's already here, okay. Prometheus community exists with the same configuration, skipping. That's why it's skipping. I will add Helm update, okay. Now we already cloned that repository, right? So we need to search that all that chart belongs to the same. I mean, this is the package, right? So we need to search what are the charts that belongs to the specific repository. So using Helm search, we can search. So these are the package. I mean, these are the charts actually, okay? These are the charts. Within this chart, we need to install corresponding stack. So in this case, we will go with only one stack. This is stack actually, Prometheus community Cube Prometheus stack. So in this stack, actually, what are things included? Prometheus, Grafana, and the dependency for the Prometheus, some microservice applications there. So all that specific application will running in our Kubernetes whenever we install this specific task. So I am going to create a namespace for this deployment, Prometheus. So this is created in Kubernetes, okay? So now we are going to install the stack, okay? The above stack we discuss, okay? Using Helm. So this is the command. We're talking with the Helm to install stable Prometheus community stack. So we need to define the stack from above, okay? This is the same stack we defined here. So this stack we are going to install using Helm. And we need to define the Kubernetes namespace as well, okay? So Helm is actually a native application deployment for Kubernetes. So the Helm looking for the Kubernetes namespace as well. So it will configure, I mean, it will creating the pod and everything, container. will take some time. Okay, it will taking that repository YAML and taking the corresponding configuration and it will install. Yeah, it's completed. Now you can see this is a similar output. Okay, when we're using Helm package manager, get port namespace Prometheus. See, so these all that port created using the Helm command within a single command. You know how quickly we deploy every app, all the application, right? Otherwise, we need to create separate YAML for all these port. Also, you can see there is a service also for the same kubectl. See all the services you can see for the specific application. So this is a port, and for the all those ports, there is a service also mentioned. All the services configured as cluster IP, right? But our requirement is we need to change two services and we need to expose two services. Okay, one is stable Grafana so that we can access the Grafana and the Prometheus as well. So how we will expose? We can edit the service. Okay, there is a service YAML actually there. So we need to take that service. So we need to take the service. So kubectl edit SVC. We are going to edit SVC. Then we need to define the service name. Okay, stable kube Prometheus, STA Prometheus. So this is the service actually created by using Helm. And we need to define the namespace as well. So it will open the specific service YAML file. So this is a YAML file for the specific service. And here we need to change the type as load balancer. This is Vim, okay? So type I to insert mode. Remove load balancer, L capital, B capital. 7 exit. So escape, double colon, right, quit, WQ, hit enter. So at the same time, you can see it's edited, okay? That Kubernetes taking that, and you can see now the load balancer created. See, now one service changed. The Prometheus service is changed to load balancer. Also, at the same time, it will create the load balancer as well. Copy, paste. We need to define the port number as well, okay? For accessing Prometheus. So same way, we need to expose Grafana as well, right? Because these tools are mostly we accessing Grafana actually. It's a graphical dashboard that we need to share with the L1 team as well. So I'm going to edit Grafana configuration. I mean Grafana service YAML and change that I type cluster IP to load balancer. As of now, the load Grafana will accessible within the cluster only. Now we are going to expose it outside the cluster. Save and exit. See, now two load balancers are created for Grafana as well. So copy the DNS of and go back, paste here. So in that Kubernetes, EC2 dashboard, go to load balancer. We can see both load balancer, okay, for Grafana and see these tools are for one is for the Grafana, one is for the Prometheus.
Going to take some time to access the application using the.
Sorry?
Does it gonna take some time to access the application through load balancer?
Right. It will take some time because just now it's creating the load balancer. Whenever we change that type to load balancer, it will create the load balancer. Some background processes are there. Now we can access Grafana, right? Prometheus default port number is 9090. See, for Grafana it's 80, so we did not mention that. For accessing that Prometheus, we need to define the port number as well. I don't know that port number 9090 I can access from my machine. Copy. Can anyone check from your side? It will work. So now we can see we successfully log into Grafana dashboard. Default password admin, I think.
Yes, I can access.
Yes. So just to go to the target, there is an option card. So there we can see our cluster is up or down. If up, then it's success.
Graph, okay.
In top, there is some options there, right?
It says table graph explain.
Then
Alerts status.
just to drop down anything and you can see
Drop down
target.
target health.
Target L. Click on that.
Oh yeah.
It's showing up, right? Yeah,
Mhm.
that's fine. Yeah, that's fine. That means the service, Prometheus will taking all the scraps, metric scraps from that Kubernetes. So it's collect everything. Now we are visualize that metrics using Grafana. So we need to see, now I am logging to Grafana dashboard. So here we can see a lot of stuff. So first thing is we need to add a first data source. So click on that. Our first data source is Prometheus. So here you can see a lot of data sources are there. So as per the requirement, we need to configure corresponding thing. So these all data source available for Grafana. Okay. So in this case, our data source is Prometheus, right? So we need to select Prometheus. So we selected the Prometheus, and we need to define that Prometheus URL as well. Okay. So the name is Prometheus one, and the connection type we need to define here, Prometheus server URL. So we need to copy the same HTTP. Yeah, this is fine. So we need to include the port number as well. Okay, 9090, also using this HTTP. Okay, that's fine. So we provide that Prometheus URL. That's fine. We need to save and test. Okay, if this testing, we can see if any error or not. Yeah, this is successfully queried API. Sorry, Prometheus API. So now we can build a dashboard. Okay, this configuration is done. Now we can go to that dashboard, and here we can import dashboard. Okay, click on that import dashboard. Click on that. So now we are going to create some dashboard for monitoring. So we can coming to Grafana, we can provide dashboard URL or dashboard ID. Okay, so some predefined IDs are there. So for example, you can see 12740. This is for just to load. Okay, we can see for dashboard. Yeah, this is for Kubernetes monitoring dashboard. Similar way, some other IDs are there for 3919. You can check. Yeah, Kubernetes cluster monitoring. This is entire cluster monitoring. And the first one is for specific pod monitoring. And similar way, we can select, corresponding dashboard we can onboard, okay, here. Whenever we import dashboard. And now I am going with this one, okay. You can see the cluster monitoring. And we need to select the Prometheus dashboard as data source as well. So scroll down. So don't go with the default, okay. We created a dashboard named with the Prometheus one. Select that one and import. That's all. So it will create the dashboard for us, to including all the data as. See, this is a container usage. CPU. These are the different application in our Kubernetes cluster, okay. Proxy. Container memory usage. One container taking too much. Yeah, that is related to Prometheus. These all the details came from our Kubernetes, okay. Also, we can see the total our Kubernetes data. RAM size. This is the RAM size. Also, the NA is not getting any detail, okay, from. We can go with another dashboard. This is Kubernetes cluster, okay. Or so this coming to this one, we can see how many deployment replicas there, how many deployment updated there, number of node out of disk is not available here. Running port, that's 18. Container running. Because some port, okay, here you can see 18, right? Some port contain more than one. Okay, that's why here 25. Okay, we'll check with the port. This is another dashboard, Kubernetes port health of. Okay, this is a deprecated one, okay. Migration. So this way we onboarding, configuring Prometheus and Grafana inside our Kubernetes. So coming to the dashboard, okay, just to go to dashboard, we can see a lot of dashboards here. So click on any of them, alert manager overview. This is predefined, okay, just to go to dashboard. We can see Kubernetes API. This is just a starter though, so that's why it's from here we can start. See, we can sort by specific node as well, okay. So this is for the CPU and memory utilization, how much will take. See the namespace in our cluster, kube system and group proxy. See the receive bandwidth, transit bandwidth, average container bandwidth. So as per the requirement, we need to configure and see whatever. So I'm just opening that Kubernetes, Prometheus namespace. So we can see that port running on the Prometheus namespace as well. I'm opening that specific Grafana pod. Okay, so the pod usaging everything we can see here. This is specific for the CPU utilization. Okay. Got it, all of you. Any doubt? All good, right?
Can you share the documentation related to this, like downloading
I'll
the
share.
Helm, like commands to download everything?
Okay, okay.
Also, yesterday and today's video,
I will
Friday
share. I
and
will share.
today's.
3 videos are there, including today, right?
Yes.
Okay, I will share. Then we can wind up, right? There is time is 10:30, right?
Yeah, for EST it's 10:30.
10:40. Yes.
Okay, is this time is good, right? All of you.
So we're going to start at 9:30 from tomorrow.
9:30. I will check that time. 9:30.
For
Which
you it's
which
7.
7, right?
For you it's 7. 9:30 EST, 7 IST.
Yes. Actually, we are conducting 7 a.m. right? Today also I'm starting 7:05 or something.
Yeah, we
Yeah, the
we
US
had
time
it.
clocks moved ahead by 1 hour.
Yes, 1 hour. So
Okay.
I think if everybody like be sharp on 9:30, then we can start and wind up quickly.
Okay.
Okay.
Yeah.
Okay. Have a
Thank
good
you.
morning, Tawfiq sir. Good night, everybody here. Thanks for the class.
Can
Bye.
we can wind up, right? All of you.
Sure. Sure.
Then I will share with the recordings and resource. Okay, so just to try it on your info.
Sure.
Okay, thanks.
Bye. Bye all.
Bye.
Good night.